So I have the pleasure of being the only presenter that doesn't work for Apsera today. Although Derek is going to pay me afterwards. So I know everybody doesn't know me. My name is David Williams. So today, thinking about what to present, I have to start thinking about, okay, do we talk more about the in-depth technical discussion? There's no need for me to do that because you have all the experts here in the room with you. Or do I talk about usage? And my background is more in the enterprise space. So I started to think about, okay, when everyone thinks about messaging, they think about integration. When you think about integration, you think about integration patterns. So today I'm going to talk about integration patterns specifically for microservices architectures. But I'm not just going to talk about integration patterns. I'm going to talk a little bit about anti-patterns as well. Because there are wrong ways to use even a great messaging system like NATS. And of course, the star of the show today is NATS, NATS in the multi-cloud enterprise. So a little bit about who we are, Williams and Garcia. We're based in Atlanta. We're a small boutique consulting company. We're focused on anything that disrupts the status quo in the enterprise. So if the enterprise is all about IBM MQ, like Derek said, we're all about doing something else. If they're all about Oracle, we're all about doing a completely different database, anything that saves them money and disrupts their ways of doing it. I have to go and put the triple picture of our focus areas in here, focusing on platforms of which, if you haven't checked it out yet, Apsera makes a great application platform as well. Cloud native infrastructure, which is focused around containers and containerization, as well as modern enterprise architectures. So a little bit about me. Why should you care about even listening to me today? You shouldn't. No, I'm just joking. You should. So my background originally started as sysadmin. Thank goodness that's done with. I'm no longer a sysadmin. Most of our consulting work is either around architecture or around product development. So 20 years ago, actually more than 20 years, but I'm not going to mention how many years, we started off in the application infrastructure space. Later that was called middleware. Now today we just call it platforms, right? There's all different types of platforms out there. And of course, the underlying infrastructure that all of that depends on. My passion was originally in the traditional enterprise IT, the things that I love to disrupt now. So that leads actually to my first meeting with NATS. And simple technologies too. So my first discovery of NATS was going and deploying this little project called Cloud Foundry. And I remember there was this one little part that everything seemed to use. And I started asking the question, what the heck is this NATS thing? What a funny name, right? NATS, what in the world does that mean? Derek, that's an acronym for something, it has to be. Not another TIPCO system, right?
You are correct.
So as I... Absolutely. Absolutely. And Cloud Foundry, although, in this room, we won't discuss too much about Cloud Foundry, but Cloud Foundry was a great example, while Derek was there, of what you could do from a messaging perspective. As you guys know the history, it started off as a Ruby project. I think Wally mentioned that. And now today, it's a Go project covering a whole bunch of different languages, different clients out there. But the way it does things is very different. Store and forward is the most common messaging technique out there. There is no persistence. There's no nature of transactional messaging either. If you need the messaging system to be smarter than your application, you don't want to use NATS. Because NATS assumes that all that business logic and all that routing logic is in your application. It just does what it does, fire and forget. So today I want to just take you through a journey and talk about some of the possibilities. What are some of the things that you could do using NATS? The possibilities are really endless, and as I talk about the patterns, after we talk about the anti-patterns, this in no way is meant to be a finite list. I think in this room, you could probably collectively come up with hundreds of ways that you could use a messaging system like NATS. So is everyone familiar with this book? Now, this was my Bible for a while. Great guys, really smart. I think today their pattern catalog is over 65 integration patterns. That's a lot of integration patterns. Here's a nice drawing from their website of all the different ways that you can do enterprise integration via messaging. This is not integration with other technologies. This is strictly with messaging. And so a couple of things that if you go through their website and you read about the history behind each of these patterns, you realize a couple of things. They use the word harvested. They went and did a big study, harvested all these different patterns and documented it in this great book. And it really is a good book. I'm in no way knocking the book. But you realize that as you start to read through it, this was a different day. This was a day back when applications were tightly coupled. That's the antithesis of microservices, right? This is when all the applications were large monoliths. You know, we were all counting how many lines of code was our application, right? You wore the badge of pride if you had the largest application out there. Most of it was written in a single language, and in the enterprise, Java dominated. And then the messaging systems were big and complex. Ask any of the former TIPCO people here. So obviously, this was a world before microservices. So although I think you could still take advantage of a lot of those patterns in there, unfortunately, trying to do a lot of them actually becomes anti-patterns. So you may have a big problem that you want to solve, a real problem, and by trying to solve that problem, you create a bad solution, or I'll be politically correct, an inappropriate solution, all right? So let's talk about well, actually the most common anti-pattern that I've seen when companies try to decompose their monoliths and try to refactor them as microservices. Does everyone know what a stovepipe is? All right, I'm going to tell you anyway. So basically, it's when you take something as it was before and you try to do it, in particular, what we're talking about in a distributed way, the exact same way you used to do it. Has everyone worked in a company where the old application did things a certain way and it wasn't working well, so you decided to refactor it, but in the refactor, you did everything the exact same way. And you wondered why, geez, why isn't it getting better? As a matter of fact, it's worse. So unfortunately, a lot of enterprises that are trying to adopt microservices now, they find themselves in this anti-pattern of stovepipes. So here's a few different things that I just randomly picked a few. I try to categorize them out of that catalog of 65. So Derek, correct me if I'm wrong. These are a few things that you should not do, in particular with NATS, right? Should not make it transactional in nature. And if you go back to that website, you'll read up about some of these patterns. Transactional client, it's right in the name. Competing consumers, message expiration. All these things are somewhat transactional, where you're relying on the messaging system, not even the client, to do things for you. You should not do that in micro-messaging. You know, that's my tag word here. Micro-messaging, messaging, and microservices. You shouldn't require that messages persist. If you do need to persist messages, and I'm going to go over this soon, there's other ways that you can persist data so you survive any kind of disruption or failure in your system. Notice that the guaranteed delivery is in red. The next slide, we'll talk about why that's in red. And then next, your messaging system should not modify or selectively choose what messages to send and not send. Became a really popular thing through the 90s, 2000s, even I think they're still doing it today in a large part. But a messaging system should just take the message that was published. The publisher knows best what that message should have been and should just pass it along. And that's what NATS does. So, by the way, I'm going to throw a ton of memes out here into this presentation, so enjoy them while I send them. We talked about that red section where it said guaranteed delivery. So let's go ahead and realize that exactly once is not really possible. And there's a great article out there that talks about it's a fallacy to actually think that you can have an exactly once guaranteed delivery messaging. There's so many factors that can mess that up. And one of the ways that we're going to talk about using that just pretty much says, hey, just like microservices, expect failure. Right? Don't try to have maximum resilience and availability. Instead, expect failure. I didn't get a lot of laughs with that meme, so hopefully the next ones will be even better. All right, so what are good patterns for micromessaging? So these are the three basic ones. Derek just mentioned them a little while ago. Pub/sub, queuing, and request/reply. You can do a lot with these three. There's obviously other ones out there. I think does anybody here use a messaging system today? I'm going to be a little bit more interactive. I don't want to talk to you. Okay, so can we start throwing out product names? What do you use? Okay. Oh, that's right. Sorry. So I don't know who's an Apcera employee here and who's not. So So I'll throw some out. TIBCO, obviously. Anybody here use RabbitMQ? ActiveMQ? Okay. Yeah, that's an interesting. ZeroMQ kind of disrupts a little bit, but it still maintains a lot of those older paradigms, right? Okay. Okay. And that's available on Azure. You mentioned Azure a little while ago, right?
Yeah, I have used it, but not in Azure, but something.
Okay. All right. So these are the three basic things. I don't know if the roadmap, Larry will talk about the roadmap later. These are the three basic types of messaging that NATS is capable of doing today. So let's talk about how we can put those to use. I didn't want to harp on the anti-patterns. We're going to go ahead and just talk about the patterns today. So I'm going to start with the really simple and obvious and gradually get to the more creative and possibly absurd. But it's just to prove a point that any of this is possible. So today, probably one of the most common ways of using NATS in microservices is inter-service communication. HTTP REST APIs, those are great. Service endpoints are great. We talked about scalability a little while ago. They have their limits on scale, and there's a lot of other issues with them as well. I personally like the, Martin Fowler, I think, said you can either have service endpoints or you can have dump pipes. And I personally prefer the dump pipes method. It makes it really easy to add new services, auto-grow or shrink your microservice. And then all they have to do is just pay attention and subscribe to the queue and do what they're coded to do. You don't have to get into a whole lot of service discovery, registrations. You don't have to do a lot of that. Not that that's a bad thing or there's not a place for it, but in this pattern, you know, I'm showing here in this drawing, some of them do have a service endpoint, but all of them can participate in the queue. It's a very lightweight client, very easy to communicate with other services this way. So this is probably the most obvious of the patterns for microservices. Next is control plane. You see this both with, I'm assuming, with Apcera's platform. You see it with Cloud Foundry. This is basically where you have some kind of service. To me, it's still a microservice that wants to go ahead and send control messages to other services, you know, start or stop, write or read, you know, all these different types of things that you could do. I think this was a pattern that would work very well with Internet of Things. There's lots of other use cases for it as well. By the way, if you can't tell, all my things are really ambiguous. I want you to creatively think about how you could use this in your own organizations, in your own applications. Heartbeat, that's another common one, right? Heartbeat's really easy. Hey, this is my status, this is what I'm doing, this is my health. And in a way, you could almost have services manage themselves. So hey, in this case, they're heart beating how many instances they're aware of, and they can do some kind of consensus for knowing whether they need to tell the controller to start up another instance or not, for availability's sake.
At the controller side, right?
The controller, right. But the controller needs the information, and the easiest way to gather the information is for the services to send out heartbeats. Imagine trying to send out heartbeats over HTTP for thousands of service instances. That would, on Amazon, just imagine the network costs of just doing that alone. All right, so now we're going to get into a little bit more of the creative ones here. And if I'm going too fast, let me know. You don't have to wait for Q&A for me. You can just spit it out if you have any questions. This one I'm actually really passionate about because we had a conversation earlier about this, real-time stream processing. Hadoop was all the rage. That was so like 2004, 2005, right? Doing everything in batch. But today it's all about real-time streams. And again, IoT, I think you asked about IoT before. It's all about all these sensor points, all these collection things, simultaneously and continuously sending information. So here's a pattern for real-time stream processing. You have all these different NAT clients. Remember, it could be a Go NAT client, a Ruby, a Java, a Lua, a Haskell. I mean, all these different endpoints that are sending to the NATS cluster, sending it off to some real-time computational mechanism, and then maybe even sending that to some server-send event system, microservice for publication in a UI. So I'm going to go a little bit more in depth into this one as an example. So everyone here familiar with Apache Storm? Right? Apache Storm is, I hate to use this, but it's taking the world by storm, right? Because it's now the new darling of real-time computational work. So it would be very easy to write in any of these languages a spout that could take that information and inject it into Storm. Everybody familiar with spouts for Storm? It's kind of like the ingress mechanism to get data into Storm. Once it's in Storm, you can decompose and you can parse and you can do everything, creating the bolts for it in whatever topology you want. And then you can send it right back as your final bolt back into NATS, and then have like a Node.js app sitting there waiting for those events to come in and taking it and sending it off to some JavaScript front end that does D3 for rendering or for visualization. So all of this can be done with absolutely hardly any overhead from the NATS client. You can literally put a NATS client on every single instance, every single node, and just have it just participating in the messaging system without it and taking away too many resources from what it does.
Processing, right? It does those SQL processing of the data.
Yep. Yep. All of that would have to be done by the, but NATS could be the way that messages move around into different types of systems, right? And the great thing about something like Storm is you can actually write your adapter, so to speak, to get things in and out, right? And that adapter at the end sends off to the messaging system via NATS. Okay, Event Store. This is another one that we've used a couple of times. We're still trying to find the perfect way to do this one. But in essence, have you ever wished that you could put a database on every application node? Okay, I have. And the problem that you have with that is you have this consistency issue, right? You have all these database nodes that have different states of data. And then we started playing around with this pattern. And the pattern, I have a bunch of numbers here, and I'm sorry I don't have what each number stands for, but I'll walk you through it. The pattern starts with a service writes to its local copy of a database. And this should be some highly distributed database. It could be React, it could be Redis, it could be all sorts of different types of things, right? NATS does not want to get involved in transactional, so it doesn't really care about the commit. Once the client gets the commit to the database, all it does is send out an event. So there's no actual data payload going out in the message. All it is an event saying, hey, data's been updated, right? It's been written, it's been deleted, it's been changed in the database. And all the people that care about it will know about it, and they'll go and take a look at their local copy of the database and go, well, I don't see that change yet. Well, then they can go into a loop and sit there and wait till that changes in there, knowing that there's going to be an update, and any information that they have today is stale. You can even do a request reply and send acknowledgement back, say, yep, I see the message, I see the data that you said was written. It's all good now. In a way, this is a way to add persistence for those that need persistence without having to make NATS do something that it doesn't do. NATS does not persist, and there's good reasons why, and it won't persist. But if you need data to persist, that's part of a processing pattern that you have. Well, you can do it this way, write to a distributed database and send the event out across NATS. So this is another pattern. Believe it or not, we use this for an infrastructure management tool, so it's not even like for a fancy app, but it worked really well. We also use this to let different systems know that data cross-region, cross-national replication occurred for a SQL Server database. So it was actually, you can get really creative with this particular pattern. All right, this is probably the most creative one I think I have in this slide deck here. So you could use NATS as a universal database driver. Wouldn't that be great if you could have a database driver for every database platform out there for every language that NATS supports? So this is what it would look like. Microservice simply sends a JSON payload via NATS, a message, and all these different data services are subscribing, right? So they receive the subscription, and then they have all the code to parse through that JSON and write to the particular database platform. So imagine microservice A, for whatever reason, wanted to write to Mongo and Postgres simultaneously. Well, all it has to do is just send out a JSON payload through a message, and on the back end, it gets committed to Mongo and Postgres. Didn't have to worry about making sure I have the right database drivers, making sure I syntactically know how to do my SQL or talk to that database platform. I'm doing a universal data communication, just sending it out in JSON. And it persists on the back end. Again, NATS is doing what NATS is made to do. NATS isn't involved in that at all, but this is how you can build an ecosystem and architecture around NATS. So let's talk global. There we go. So one of the patterns that we've used before is a Bridgehead pattern. And Bridgehead, this is actually a pattern, believe it or not, that I thought of coming from an Exchange background, Microsoft Exchange. Probably nobody here uses it anymore. Everybody's on Google, but So in Exchange, you had the concept of sites. And to get a message from one site to another, you designate an Exchange server as a Bridgehead server. Active Directory does the same thing, I believe, too, for multi-site replication. So why can't you do that in messaging? So this is another pattern. Again, I'm moving towards the absurd as we go further down through the slide deck. But you can have a cluster for Site West. This is the San Francisco cluster. The East Coast cluster could be across the pond over in London. And then you have bridge points that are subscribing to queues and also publishing to recipient queues on the other side. And it basically becomes a relay. Its whole purpose is to be a relay.
You acknowledge by design that communication between two sites are slow.
They're slow, so you have a kind of like a concept of eventual consistency. It will eventually get there. But it is a way to get that message there, right? And even though it's slow, you can't go any faster than the pipe you're going across, realistically. But I thought this was an interesting one. Again, just getting creative, right? Take those three simple design patterns, a pub sub, queue, and request reply, and what can you do with it? All I'm trying to do is just, you guys are the creative geniuses in this room, and I'm just trying to plant the seeds of what could you do here. So why should developers have all the fun, huh? And do we have any ops guys here? Or DevOps guys? I am the only one in the room. Oh, wait, Josh, Wally, okay. So this pattern I call DevOps Gone Wild. I'm trying to get creative with the names. So this is messaging as part of your DevOps toolchain. Whoa, what's that? So Ruby, great scripting language. Don't need a compiler. Every sysadmin should know Ruby, just like a long time ago they should know Perl, right? Is there a Perl client yet? I guess there's not a Perl client yet. Somebody needs to do that one. So imagine if you're doing your CI tool, and I'm going to go ahead and throw a plug for Concourse CI because that's our new darling. Jenkins has had enough attention. Concourse CI, if you haven't seen Concourse CI yet, you should check it out. So imagine you had a CI tool that wants to go ahead and instead of doing like some kind of webhook like it does with GitHub and other things, it goes ahead and sends a message out. Right? So you have some little script, Ruby script, that uses the Ruby client and sends a message out. And whoa, all of a sudden it gets picked up by your configuration management tool, let's say Chef or Puppet or whatever tool you have. Or it gets picked up by your favorite container scheduler. So some system that's interacting with Mesos, Kubernetes, whatever it is out there. So basically your CI tool was able to manage the provisioning and the configuration of your infrastructure using messaging. Why not? You may not choose to do it, but it's definitely possible. And you may find some interesting use cases that otherwise would have been a little bit more troublesome to go through. So global domination is my final design pattern. Everybody has to see at least one of these all things Mimi. So one NATS to dominate all the things, right? So the idea is, and Derek, this is just for you, all services everywhere communicating via NATS, right? Don't be like this guy. Finally, some laughs. It's about time. And in summary, my whole objective today was just to have everybody rethink how they do communication. Messaging may not be the solution for everything. NATS is definitely a great messaging system, highly performant, very lightweight. I think we're down to 2 megabytes for the Docker image, compressed. I mean, that is extremely, extremely small. So, hey, we have some non-App Server people actually clap to that one. So I'll take your questions now if you have any questions that you haven't asked yet. Wow, that's a question.